session change happen? Also at last minute irgendwie personal circumstances, whatever.
Okay, let's get started. Welcome, Reactor friends, at the Berlin office here in Unter den Linden, and of course also in the stream. Today we have another series of the Berlin Reactor pop-up, and today it's all about mastering applications at scale on Azure. We start with the Azure Developer Community Call. The hot topic will be Azure Mission-Critical by Sebastian Bade and Martin Simicek. The second session actually is a replacement. Our second speaker was not able to hold a session today on short notice, unfortunately. But the good thing is that Sebastian and Martin, they will do a hands-on session about the Azure Mission-Critical framework in the second session, also very interested. And then the third session will be CQRS 3.0, the serverless solution by our MVP, Janek Fellien. Okay, with that, let's get started. And as usually, we start with the code of conduct. So Microsoft is dedicated to empowering every person and every organization on the planet to achieve more. This includes Microsoft Reactor events like this, where we seek to provide a respectful, friendly, professional experience for everyone, regardless of gender, sexual orientation, physical appearance, disability, age, race, or religion. We do not tolerate any behavior that is harassing or degrading to any individual in any form. Individuals are responsible for knowing and abiding by these standards. We encourage everyone to assist in creating a welcome and safe environment. Okay, now let's get started with the Azure Developer Community Call. I will quickly show you what we are going to do in the Azure Developer Community Call, which is always the first session in our Reactor series events. So we will present you with some community news, Azure service updates and announcements, and then we start with our first session of today, introducing the Azure Mission-Critical framework. Okay, we reworked the Azure Developer Community a little bit. We started with one developer community call a month last year, and now we have a lot more. So we have, for example, a news and hot topics call or session, which is this one now. And we also have an Ask Me Anything session where our cloud native expert, Dennis Sierke, is answering all your questions. So we highly recommend to join these sessions as well. I will show you where you can find more information about that in a second. We also have the Dev Community Hub on GitHub. So it's a public GitHub repository where we share a lot of information around Azure, about our Azure upskilling activities. We have an awesome Azure list there as well. And we also like you to contribute if you find something very interesting about Azure or a certain SDK or anything, example applications or something, you can put it there as well. And by the way, we now have a lot more than 15 stars. We should update that image maybe. So please check that out as well. It's AKAMS AZ Dev Hub. So we also have a private LinkedIn group. If you want to join our private LinkedIn Azure Developer Community group, then you can scan this QR code and we let you in. Then a little bit about past and upcoming events. So this is about upcoming community calls. On March 2nd, we have the next Ask Me Anything session. If you want, just take a picture of the QR code as well. The topic will be optimizing costs for your cloud native workloads. And as always, Dennis Sierke will be there to answer your questions. Then on March 30, we have the next news and hot topics developer community call, the same one like this one. The next Reactor session in March at March 30 will be about web development. So we will have 3 sessions about web development. Chris Heilmann, if you know him, will also be holding a session there about web development. And on April 20, we have the next Ask Me Anything call the topic will be about multi-region deployments. Also very interesting. So yeah, just grab a picture and then you can later maybe use the QR code. Okay, and here we see it, the next Reactor events, of course, is kind of redundant. March 3rd here again, will be about web development, and April 27 will be about Python. We don't have an exact agenda yet, but since PyCon will also be in April in Berlin, this is a good opportunity to meet people with the same interests, right? Python. Okay, and finally, if you're here today because you registered through the Azure Meetup Berlin group, so Janek's group, then we also like to invite you to join the Microsoft Reactor pop-up Berlin group on Meetup, because next time it might be that Janek is not publishing an event in his group for our next Reactor meetup. So if you want to make sure that you don't miss out any meetup events, then yeah, join that group as well. So with that, enough of QR codes for now. And I will tell you a little bit about the latest Azure news and updates. And so usually we have like our most favorite picks, like 5 to 8 announcements which we share in this Azure Developer Community Call at the beginning. So what has happened, what has been announced, what has gone GA, so generally available in the last couple of weeks. And today we start with Azure Machine Learning. New features are now available in public preview, include the ability to build an end-to-end model training pipeline without needing to write any code, track whether a new version of your compute instance is available, recover workspace to ensure little disruption in your work operations, create schedules to automatically run jobs on any regular basis, and gain insights into potential root causes of pipeline failure. So you can train models using AutoML in Designer. So that means you can now drag and drop your data, hook it up to an AutoML task, and deploy the resulting best model. This is just a screenshot I took here to demonstrate the low-code, no-code solution there. By the way, this is a perfect solution for no-code, low-code users who want to build enterprise-quality machine learning models on Azure. The next pick of one of our 5 or 6 favorite picks this month is Azure Storage. We now support 5 GB put blob. This allows you to upload nearly 20 times the previous limits of put blobs. So we increased it from 265 megabyte to 5 gigabyte, which I think is sufficient. So next update is about Azure Kubernetes Service, and it's about pricing tiers because there were some confusion. So maybe you know that Azure is the only cloud provider who offers a completely free AKS, so Kubernetes control plane. And but of course, this free control plane or AKS mode is not coming with an SLA. So, and if you want to have an SLA, then now you can choose between the standard, which was the free tier, or the free tier and the standard tier. So the standard tier is the one that costs around $72 a month, but that offers an uptime SLA, and the free tier, of course, doesn't offer an SLA. So then, I'm not sure if anyone has heard about Azure Web PubSub, but Web PubSub makes it easy for you to add real-time two-way communication to your web and mobile apps without worrying about infrastructure. And this premium tier plan provides greater resiliency, scalability, and flexibility by enabling key enterprise-grade features, for example, availability zones or auto-scaling, or an SLA of 99.95%, custom domain support at your desired custom domain names to your applications, and so on. So take a look. So Web PubSub is an interesting service. And then, yeah, finally, Azure load testing went GA, so it's generally available. We are introducing this as of today or last week, something like this. Azure load testing is a fully managed load testing service that enables you to generate high-scale load, gain actionable insights, and ensure the resiliency of your application and services regardless of where they are hosted. Developers, testers, and engineering teams can use it to optimize application performance, scalability, or capacity. So if you want to test out your applications, then I can really recommend to check out Azure load testing. So with that, I like to introduce my next speakers. And you will see first, our first session of today is introducing the Azure Mission-Critical framework. So, stage is yours. We need a second to change laptops here. Yep, I take that with me. Have fun.
Thank you.
Thank you. Is this working? It is working.
It is working, yes. And if we can please switch to our slides.
Perfect. Thank
Perfect.
you. Thanks for the intro, and thanks everyone for coming and joining us this evening. My name is Martin Šimeček. As you can probably tell, I'm not from Germany. I come from the Czech Republic, not too far. And my colleague here is Sebastian Bader. He is German, and we both work for Microsoft as engineers currently, but also cloud architects. And we are, I think we can say we're developers by heart.
Yes.
So that's what we enjoy doing. And we are talking to you today because our team has developed a framework and architectural guidance, which we call Azure Mission-Critical. And it's about running mission-critical applications in Azure.
Yeah, not much more to say from my side. So yeah, I'm Sebastian, based out of Munich here in Germany. Yeah, and without further ado, let's dive in.
Get into it.
Actually, a couple of the new topics that Thorsten just mentioned before we'll see again, like Azure load testing. So that was a great intro there. We'll actually have a demo. Yeah, overall to say, we'll try to do as much demo as we can. That being said, we probably all know some demos work, some don't. So bear with us, but we hope to make it interesting and show a couple of slides, show some demo, go back to some slides, but actually not that much slideware today. Oh, sorry.
We need to fit into the camera. That's why we're doing this.
That's why I like kind of huddle here.
Yeah. So hi, everyone on the stream. We do this for you. So just warning, we will do always some kind of a context setting. So we will explain the concept, but then we will try to get technical. So we will try to get hands-on as much as possible and really show you the details on demos, how things work. If you have any questions, feel free to ask, I think, straight away, right? We can address anything, but there will be also breaks, so we can definitely talk directly. All right, now let's get into it. The most often question, or the most frequent question we get when we start talking about this is, what does it mean? What does it mean that an app is mission critical? And the issue with this is that it's individual. So everybody, every company, every person, everyone running some kind of an information system has different perception of criticality of that system. But in general, we consider mission critical apps those apps which should be always on and which should never go down. It can be a financial system in a bank, but it can also be matchmaking on Xbox Live, for instance. If either of those apps don't work, there are different things which different effects on the company. So if Xbox Live doesn't work, it's more of a
like a loss of reputation,
reputational issue. Yes, thank you. If the bank doesn't work, or if an e-commerce site doesn't work, it's a loss of business. It's direct loss of money. Both of those apps are mission critical, but in different ways. But we try to target these kinds of scenarios, applications which should not go down. That said, this is a general guidance and set of opinionated recommendations on specific topics. So you might find yourself interested in a specific topic, and even though you're not running a mission-critical application, you can still apply these things, these recommendations and considerations. It's just about picking the right things. You might be interested in load testing. We have some kind of a guidance for that. You might be interested in global routing. We can show you how to do it. And we can go next because we are talking specifically about Azure Mission-Critical. And that's the guidance we've built as a team. And we took a lot of the information that's already available on Microsoft Learn and Microsoft Docs documentation sites under the name of well-architected framework. There's a lot of stuff. There's a lot of good information. We took all of this and we sprinkled a little bit of real-life customer experience on it. Because we work with customers who typically run mission-critical applications. So we added this experience into it and we created guidance. So you will find opinions, recommendations, very specific things in this guidance. And it's always explained why we recommend this. And that's what we'll cover today. We actually developed it kind of in reverse. So it wasn't guidance first and then try how it works. It was the opposite. So we first implemented what we thought was good. We call it reference implementations. And only when we validated that it really works and that it's really how it should work, we wrote the guidance around it. And you see all of that. It's all open source.
Yeah, and a word about the reference implementations, it's not just stuff that we came up with and we tested internally. Most of it are things that we used in our customer projects and validated with the customers that it works and how we think it should work before we put it in the reference implementations.
Exactly.
Yeah. And so you'll see it later as well, and if you look into it later, the reference implementations, we try that it's not just another set of sample code, right? There's a ton of sample code out there. We really try to make it an end-to-end demonstration and a starting point that you guys can use to build your own systems. And again, you can build it to build mission-critical apps, but you can also say, okay, if I want to implement load testing, how do I implement load testing for real? Not just another quick sample. How do I do it for real? You can take the pieces of the reference implementations. That's the idea how to use them.
Let's move on to key principles.
Yeah. So those are probably the 4 main key principles we kept in mind when we built the architectural guidance and also the reference implementations then that we're going to look at for the next hour or so. The first one is we want to build active systems. And also Torsten mentioned it, one of the next community sessions is about multi-region deployments. So that's one of the key things behind that. We want to build systems that span more than one Azure region. And whenever possible, we want to build an active way. Meaning many regions, there can be n number of regions are running at the same time and are able to handle all of the traffic that's coming in. Why is that important? Well, if one region goes down, we want to have full reliability or full resiliency regarding this one. Which brings to the next point, the key principle. We want to distinguish between global and regional resources in order not to create any single point of failures. We'll see that later as well. That means we don't want to have any single resources which are bound to a single Azure region, which could create a single point of failure. Next one is a stamp and scale unit deployment concept. So we want to have our deployment module in a way that we can add and remove them as needed, either for scale out because of performance demands or because of regional expansion. If you're a company who's currently running across 3 countries in Europe and next week you want to move on to the US, you should be easily able to also add another stamp in the US, for example. And the last part here, which is super important for us, is operational automation by design. Everything we build there is fully automatable, that's the word. It's both. Meaning the entire thing should be able to deploy it without any manual intervention. And we literally mean all. So some things we took a lot of effort, some things we didn't do at all because we couldn't automate them. But the idea is everything from the infrastructure to the pipelines that deploy them to, of course, the code build and deployment is fully automated as pipelines. All right, with that, let's take a first look at the architecture.
So how does such system look like in general? This doesn't have to be necessarily Azure, even though it translates very nicely to Azure. I will try this PowerPoint feature, which allows me to draw on a slide, and we'll see if I'm able to do it. Pen. Okay, this works.
Yes.
So these are Tatra Mountains in Slovakia. Nice place, I highly recommend it. And this is an imaginary application running in the cloud. There are no service logos anywhere, and that's intentional because this is like the high-level conceptual overview of the key principles we recommend for mission-critical apps. So you can see here some kind of a division into global resources, regional resources. Regional resources have also separated monitoring. There's also another monitoring in the global tier. There's deployment parts, and all of this together has some kind of a reason behind it. So one of the first principles Sebastian mentioned is active-active. So we consider both, well, all of our regions as, let's say, equal, running all the time, serving requests as they come to them. And we use some kind of a global network routing to achieve that. So users go from the internet to our global router. You will see what it is for us on the next slide. And this router decides on which stamp, on which region to put traffic to. Usually it's based on proximity, but it can also be based on the fact if that particular region, that particular stamp is healthy or not. So if both of them work, then the global router will just decide, okay, I will go to Europe. And for other user, okay, I will go to the US because that's the best for them. In case something goes wrong, it will not go to the US anymore. I should use different colors, but that's what it is. Then what we have next to the global router is a data platform. We always, for these kinds of applications, we try to figure out a way how to have geo-distributed data platform. It can be relational database, it can be non-relational database. Typically, non-relational databases work better in this scenario. That's what we recommend for like greenfield applications for which it's suitable. But there are patterns achievable also with relational databases like SQL to be geo-distributed and more reliable. If we look into individual regions, we see the deployment stamps that Sebastian mentioned at the beginning. So we have, but we are using both the concept of a scale unit and a deployment stamp. Scale unit is something, is a set of resources which scale together. Because when my application frontend, for instance, my .NET Node.js application, my API, can't cope with the number of requests which is getting, the reason can be the application itself or the database underneath it. So the concept of scale unit means that these two resources have to scale together. I have to increase power on the database. I have to increase power on the API as well. But then we have stamps, and deployment stamp is a set of resources which are deployed together as a stamp, as a one thing, typically. And you will see how we do it later in the demo. I think the biggest advantage of a stamp, at least for my understanding, is that you can take this stamp and you can replicate it. So we deploy exactly the same thing to region 2, and then to region 3, and region 4, and region N. And it's always the same thing, just stamped in another region. And one of the important part we realized very quickly, and we didn't design it like that initially, but we realized very quickly that monitoring needs to be separate. Anyone could take a guess why monitoring should have a different life cycle from the application resources? You said that if it fails, you cannot monitor the application. That is exactly the reason. That is correct. Because the idea is, if something goes wrong with a stamp, we can remove it and we can deploy it somewhere else, or we can take it out of rotation, but we need to know that something went wrong, and we need to be able to investigate what went wrong. That's why we have monitoring resources separate with completely different life cycle, and they are not part of updates, redeployments, or anything. They are just there. And the global tier has its own monitoring. We'll get into this more, but I just want to say one last thing. We are not using single data sync for logging, but we are using single data, single like pane of glass for monitoring, so that you can see all those things together. And we'll show you how we do it. Anything else should I mention?
Yeah, quickly on the monitoring to give another take on this, because so the one thing is like you want to have them different from the different life cycle from the stamp, but you also want to have like not a well, the first thing you might say, oh, it's a great thing to have like a single monitoring or logging sync where all the data comes together, right? But that means like if that one region, for example, where that's deployed is going down, or like that one local Linux workspace is going down, if to stay in Azure terms, then you lose all your visibility. And that's why we separate them per region. So per region, there might be n number of stamps. In that region, they log to the same one. But across regions, we're not using the same one. But as Martin said, we're using, on top of those distributed data syncs, then we're using a single pane of glass to still get a unified view of the data. And that's what we're going to see later.
Yep. The main thing we're always trying to address is reliability. What happens if a region goes down? What do we do? So these are the main things.
Yeah, avoid any single point of failure wherever possible. That's all right.
All right.
And with that, let's actually exchange that one for a bit more Azure logos. So basically, we're still looking at the same picture. Just in this case, now we're seeing concrete Azure services that we are proposing or that we're using for the reference implementations. I'm saying reference implementations. We can talk later a bit which ones we have, but they, in terms of the application pattern, they look basically the same. So yes, we still have our global tier up there. Do I have my pen as well? Yeah. So if we start with the global router, we usually recommend using Azure Front Door these days whenever it's an HTTP workload. If it's non-HTTP, then you're usually looking at Azure Traffic Manager. But for HTTP workloads, Azure Front Door has a lot of added value, for example, integrated web application firewalling, edge caching, so caching on the edge nodes, a lot faster failover because you're not relying on DNS, so things like that. And then from there, you can have private traffic over Azure Private Link to your backends. For the data store, yeah, Martin said like when we can, we try to go for cloud native, non-SQL data store, non-relational, and that's where Azure Cosmos DB comes into play. Especially with a multi-region write capability, we can write into each individual region that we have stamps deployed to. We also have a local Cosmos endpoint, and the database takes care of replication for us. So that's a really big benefit there of Cosmos. And then container registry, but that's more like a supporting service there. Inside the stamp, so if we look inside the regions, and in the easiest case, we can think of, okay, we deploy one stamp per region. So one stamp in West Europe, one in North Europe, one in UK, and one in Germany or something. But you could, based on need, also deploy more than one stamp in a single region. Usually, it's enough to have one stamp per region, but that depends a bit on your application. You could also do things like one stamp per availability zone, if that fits more for your application pattern there. But by default, by the way, we're using Azure Zone Redundant services for all the services. So Zone Redundant configurations, big Zone Redundant storage, Zone distributed clusters. That's just a given. Inside each stamp, we can see the exact same services. As Martin said, we replicate the stamps. They all look exactly the same. What is in there? In our case, we're using AKS for our compute tier, just because, well, A, that's what most people are using these days. Plus, it's a very well-suited service for this case. But the important point here, it doesn't really matter. So what's inside the stamps, that's highly specific to your application. You could be using Azure App Services for your compute tier, container apps, maybe even functions if that works for you. As long as it suits your reliability needs and it suits your application, you can run whatever you want in there. Like in our case, for the reference implementation, we're using an event hub there because we also want to showcase some like decoupling of front end and back end. Maybe your application doesn't do that. Maybe your application uses service bus instead. Maybe you don't have a key vault. Well, probably have a key vault, but maybe you don't have a website in there, right? So the important thing is inside those, inside the stamps, So basically this here will be highly specific to your application. But the general pattern we've seen being applied like across a whole number of applications, still with a switch or break up into the global resources and numerous regional stamps. Then for the regional monitoring, well, we're using Azure Log Analytics as a main data sink, application insights on top of Log Analytics for the application traces, and we'll see some demo of that as well. And the storage is just for like long-term storage of the logs data, because we don't want to keep it in Log Analytics forever due to the costs. For the repo, we're using GitHub, mainly because it's much easier to just open source it to all of you guys, which it is. And then we're using Azure pipelines to do the deployment. And there's also a reason why we use pipelines and not GitHub Actions. We started that thing like 3 years ago, I think, by now. Back then, GitHub Actions definitely were not at the same level that we required them to be for the complexity of the pipelines. And you will understand when you see the pipelines. By now, it probably has changed a lot. Recently, we've been working more with GitHub Actions, so we might eventually migrate there. I think by now they might be suitable for this purpose, but we didn't get to migrating them yet. So we're still using pipelines for that.
There's one logo missing.
Which logo?
Which logo is that? The purple one?
Which was the purple one?
We are using Terraform for our infrastructure as code.
Thank you.
So that's not on the slide, but it's a very important part of that.
Yeah. So it's not so much important that we like pick Terraform over ARM templates or like Bicep these days. We still get the question why. We picked it because, well, many of the customers we are working with are using Terraform. Most customers these days are comfortable with Terraform. We are too. Most of us personally, we are very comfortable with Terraform. Microsoft, as a company, we don't really care. Like, if you as a customer, if you're using Terraform, please go for it. If you're using ARM templates, go do. The important thing is that you're using a declarative form of infrastructure as code, and so usually it's one of those two. And which one you pick, we don't really mind. So yeah, we pick what we are comfortable with, plus with what most of the customers that we are working with are using. So Terraform it is. And we're still very happy with it too these days. There are issues here and there, as we probably all know, but no, generally I think it works pretty well for our purpose. And with that, let's dive into more specific topics of this. So we picked a couple of deep dive areas. We can talk about this probably for days on end. We don't want to do this today, so we picked a couple of hopefully interesting topics.
One of them is resiliency, because that's probably the main point when what people think about when thinking about mission-critical apps, and the capability to self-heal. If something goes wrong, I, as an operator or as a DevOps person, I shouldn't, well, ideally I will learn about it, but I shouldn't be required to do anything. The app should heal automatically, recover. And only if that's not possible, I should intervene and do something, like help it to keep working. And one of the biggest places, or the most prominent places where you can see this, is in automated traffic switching. That's why we are using what we are using front door for, amongst other things. And that's the traffic split and the traffic basically moving around individual regions. So in a hypothetical scenario, we can start with 2 regions, both serving equal amount of traffic. So in this case is 50-50. If we had more, we would just spread it evenly. But then if one of the regions goes down, something happens, and the health probe of that particular backend finds out that something's wrong, we switch all traffic, or we basically redistribute the traffic so that only the healthy regions are serving this traffic. And that's where front door is very strong, because the switch can be very quick, can be very fast. We did some demos on that. We'll see if we can show it today.
You can try.
We can try. But yeah, depending on how you set the probes and how you set the periods, it can be in a matter of seconds when you see the change of a region being unhealthy, and then suddenly the app started working again. The spike in errors is clearly visible, but it's only seconds of time. But in order to get to this point, you can't just go into the portal and just click through the settings and just configure the app. That's not enough. That's why we actually have a special pod running on that cluster. But it can be another API, it can be anything else. For us, it's a pod, which we call the health service. And that's just another, it was an API, it's not an API anymore.
It's an API.
Okay. But what the health service is doing is it's probing in the necessary dependencies. So it's always checking, like, is Cosmos available? Is Event Hub available? And there's storage also, which is important for the app. And if any of those fails, it will report a failed state back to front door. And when that happens, front door will realize that something's wrong with the stamp, with the region, and redirects traffic. We're also using the same principle for zero downtime updates, for blue-green deployments. We'll talk about it later. But traffic switching, in this case automated, is very valuable for this kind of scenario in front door.
Yeah, and the important thing is, like, front door switches traffic much, much faster than any human operator could do that. By the time that you as a human operator have realized, okay, something is wrong, maybe like thousands of users impacted already. Because usually you have some latency in detecting something's wrong, like even log analytics has like a 2-minute delay usually, and like until your data is queryable. Then you need to decide, like, okay, is this really an outage? Should I do something? Should I redirect traffic away? So we decided for the stronger approach. It's fully automated. There still will be alarms going off by the time that happens, but it's happening already, right? We're shifting traffic away already, just to be sure, basically. Like, even if, like, depends, of course, how you configure a health probe, but we're saying we rather shift traffic away from the region too early than too late, because again, we want to like minimize user disruption there. And here we can actually see one like downside of having only 2 regions. So of course you need a minimum of 2 regions to run active-active, but we usually recommend at least 3 regions, ideally even more. Why? Well, if you have 2 regions and one goes down, the other needs to be able to basically handle twice the load suddenly, right? So then either means you have like basically over-provisioned by 100% the second region, or you just need to accept the fact that for like until auto-scaling kicks in, your user experience will be degraded, because probably response time will be slower. Maybe the second region can't handle all the traffic, at least until scale out. So usually we recommend at least 3 regions there. But yeah, for this demo, like for the purpose here of the demo, and also we just pick 2 regions.
And the obvious question, why not traffic manager? We tried, it works, but it is too slow for our purpose because it's DNS based. Also, we wanted to have some kind of a protection for the app, so we made the clusters and the code work only with traffic coming from traffic manager, from front door, because we're checking the header from front door.
Well, by now it's even private links, so by now you can't even. So this is a fairly new feature in front door that you can fully hide your backend now. So front door is the only entrance point for your traffic, and then we have web application firewalling on the edge. So we're inspecting traffic before it even hits our backends.
Before we go to the demo, quick plug for developers. I need to say it here.
Please.
SDKs, especially .NET SDKs for Cosmos and for the other services, do a lot of things for you for free, like retries, switching different endpoints, switching regions, failovers. It's very easy to do. I don't think we had to do anything other than configuration, and it's really working nicely, especially for Cosmos. Like switching between not working and working endpoints is great. So I highly recommend using native SDKs.
Yes.
All right.
All right, and with that, let's go to our first small demo. It's a quick one. If I find this one. Can we please? Not sure. Oh, I need to. Sorry. Where do I stop?
What happened?
Discard. Oh, I need to stop the presentation mode first. Good to know. All right. So what we quickly wanted to show you is how our front door configuration actually looks like, and there's not too much of a demo here to see yet, but since we talked about it now, we wanted to show how this looks. So this is our, we'll see this more often now. This is what we call our integration environment. We have one environment running, which we deploy nightly updates to, and that's what we call the integration environment. So again, there's not too much here because it's a fairly small demo app, which you can actually show maybe. But the important thing I wanted to show is our backend configuration. So it's called origin groups in front door. Let's see. Yeah, so what we can see right now, we have like 2 backends. Unfortunately, it's a bit...
It's the zoom.
Yeah. You can make it smaller, but you can't see it anyway. Yeah, so we have 2 backends configured right now. They have like equal priority and equal weights, meaning front door will, and that's an important gotcha. By default, it will try to route users to the closest region based on latency. So in our backends, we can actually see it here. One is in Australia, so pretty far away, and the other is in the UK. So by default, it would just route me to UK only. But there's an important configuration you can take here, which is basically tell front door, add like another, in this case, 1,000 milliseconds to your latency calculation and do weighting based on this, which basically means like usually if I come from Europe, it will only send me to UK. But based on this parameter, it will just add another 1,000 milliseconds or subtract, not sure. Anyway, it will basically the end result, okay, it will to front door, it will look like I'm like UK and Australia are equally close to me, and then just do round robin between those 2 regions, which again might not be ideal, but for the demo it works quite well because in this case it basically means like 50-50 chance if I go from here, I might end up in Australia or in the UK. Of course, like in the real scenario, your region will probably be closer. You might use UK West and UK South or Germany, West Central and West Europe. Then it's not so much an issue. But in this case, it's also important that we get like very good distribution. Because we want to equalize equally use our regions, so the services that we deployed there. And also like if we have like 80% traffic on one region only and something goes wrong there, still with the automatic failover, like we'll have like 80% of the users who will experience some kind of disruption. So ideally try to equalize that here. And then the other important parameter that Martin talked about is the health probing. So first of all, you need to configure, okay, what is front door pinging to determine if an endpoint is healthy. So this is our endpoint, the health service. And it's how often it's doing that, every 30 seconds, which is fairly relaxed right now. Because that's a trade-off there, right? That's a trade-off because how much traffic do you want to pump to your backend? Because your backend will be hammered if I set this to 5 seconds.
But why? Why would it be hammered?
That's a good point. I just said front door, right? How many of you are familiar with how front door works? Show of hands. All right. Yeah, little excursus, which I want to talk about. Do you want to talk about it?
No, do it.
Yeah. So front door, we talk as one service, right? But front door is actually not bound to any one single Azure region. It's deployed to currently, I guess, like 120, 130 point of presence POP locations around the world. So whatever front door configuration we set is being published to all of those 130 locations. That's also why if you do any changes here, it often takes like 5 to 10 minutes until configuration is fully applied. So also like web application firewalling is not happening in some data centers or Azure regions, but like on the POP locations out there. Why is this important to note? Because the 30 seconds that we just mentioned means like every one of those POP locations will every 30 seconds hammer your backend, which suddenly means like you have like 120 times 30 requests there, right? And like we growing our POP locations all the time, so every month there's some new ones coming up. So the more and more traffic you will get to your backend. So that's always important to keep in mind. And you set this to 30 seconds and you're wondering, why am I getting so much traffic? That's why, because it's not one single thing that's pointing. And that can also mean actually, like let's say there's a POP location in Sydney, in Australia or so. That's trying to ping both backends. Here we have one in the UK and one in Australia. If something goes wrong in the network connection just for this specific location, so the endpoint might look totally healthy for like all 129 POP locations around the world, but for the Sydney one, it actually doesn't look healthy right now because there's some specific network issue that this one location can't reach UK, which is still not a problem directly because the Sydney POP location, so all the users that will enter the network through there, they will just be routed to the remaining regions. They will not go to the UK. So that's always important to keep in mind. And of course, the POP location which you as a user hit, depending on where you're browsing from, which internet provider you're using, and so on. So from Berlin, I guess we have a POP location here. I'm not sure. Otherwise, Frankfurt, probably something.
And for this reason, the path which is hitting here, which is in our case the custom health service, shouldn't do anything heavy. It's not a good idea to have like a select first 2,000 records from a database or something like that, because you can effectively DDoS yourself.
Yeah,
we did.
We did.
Learn the hard way.
Exactly. Yeah, so basically what our health is currently doing is like periodic probing of all the services like Cosmos, like Event Hub. We are actually also calling into Log Analytics to get the insights from there, trying to send stuff to Event Hub, trying to access storage. And we're just doing that periodically in the background. And then whenever a request comes in from front door, we serve the most recent result we have from that. Again, to still get a very high fidelity health probing, but without DDoSing ourselves. And how that can look like the end result. Oh yeah, quick one. This one first, just that you know what we're actually doing here. I mentioned this is our integration environment. This is running for a couple of years by now. This is the view over the last 7 days. And what you can see here is like a nice traffic pattern that we've simulated for ourselves based on some Azure functions that we've built, which simulate a traffic pattern, which looks a bit random, but also like fairly like a pattern, obviously. So we can see like overnight we have like barely any requests, which is like 3,000 per per hour or so, and then it spikes up to like 136,000 requests we're running per hour every evening. Right, so yeah, we're running some fairly okay load on that thing, just that we have something A, to show, and B, to test our stuff ourselves. We mentioned we started like implementing like 3 years ago. Ever since we've been evolving on this, and ever since this is basically being running here.
This is one of the issues with these types of environments, like integration for us. Someone calls it test or pre-production or something like that. There's no production load on those. So how do you know that they are actually working correctly without running load tests or things like that? So that's why this kind of artificial load generator, which has some kind of realistic patterns, exists.
Yeah, and ideally, of course, well, for us, of course, we don't have any real application that we're running there, so our pattern is just made up. For your guys, we'll ideally, of course, replicate the pattern that your real application is being hit with on prod. So to replicate that in some way on your integration or test or whatever you want to call it environment. Yeah, and the other metric I actually want to show is this one here. Again, this is still front door. If you look at the top one, this is number of requests and how they are being distributed to the backend or to the origins. So in the beginning, we see it's pretty much 50-50 between the two regions. And then suddenly something happened, and we can see this down here, which is showing the origin health percentage. So basically, how healthy does each origin look like from front door's perspective? And suddenly, something happened to the UK, and we can show later what that something was. So UK went down, apparently, and front door shifted traffic away from that region then. You can see like a slight increase in traffic there, but we can see how front door shifted traffic away from, and that's actually like a minute, or like even less than 1 minute here until all traffic was shifted away from that one region. If someone asks why, like, wouldn't you expect the traffic to double here? Yes, we would. In this case, the experiment, and again, we'll talk about this later, was too short, and our cluster wasn't set to scale out quickly enough in order to, like, basically the cluster needs to scale out to be handled twice the load. So for this period of time, we were able to handle a bit more traffic, but basically it means like the response time is just slower and the latency is higher. But again, it was a short experiment, and after 2 minutes, the cluster came back up, and then front door immediately shifted traffic back to that origin.
Yeah, what we're trying to do here is to not have our users see the error page, see like the not available page. And that happens for a while. There are a few requests which actually fail, but then, like Sebastian said, it's mostly slower, but I still get my page, I still get my response.
And with this, I think...
Yeah.
Is it the break time already?
Sorry, up. Can you hear me? Yeah, more or less. Yeah, that was the first part. I think we can have a short Q&A maybe. Does anyone have a question here in the room? Something. Speak up. I'm not sure if I will come with the microphone. Let's see if that works. Yeah, we have to for the stream, you know. It's working. Let's check.
Thank you. Thanks for the demo. So you showed us the first slide with the implementation where you had the resources in region 1 and region N. What is your strategy about the identities? If you are using managed identities or service principals in region 1, do you want to replicate them as well for region N? Any strategy around that?
So you mean Azure identities, not user, as in like signed in user, but
Yeah, of course, yes.
That you
Yeah,
service
so meaning
principals,
for your pipeline, your pods using certain identities.
Okay.
Yes, so for the pods and like all the services, usually we try to use managed identities, and they exist per region. So each region has their own identities, so they're not replicated. They exist per region. Yeah, good point. Like, don't share your managed identities cross region, because again, it would create a single point of failure. As we said, we try to avoid that everywhere. The deployment principle for the pipeline, well, that's one thing. The important thing about the pipeline is more, and yeah, we didn't plan on talking about this, but this is a good point. You should make sure that your pipeline has some way of redundancy. Like, let's say we're using Azure DevOps, for example, and and our DevOps instance is hosted in like Europe geography. It's called in Azure DevOps. Under the hood, that basically means I think West Europe data centers of Azure. Make sure you have a redundancy plan for that. Like, if West Europe goes down and you want to do any kinds of updates to your application, and if your application is built that only pipelines deploy updates, make sure you have a backup plan. Basically meaning like, in this case, could be like a secondary Azure DevOps instance that's hosted in different geography, or have some GitHub Actions pipeline or something that you can run at least your important deployment pipelines even while you have a major outage. Maybe you don't have to deploy your application, but maybe you need to do some infrastructure reconfiguration or something like that. So yes, have a backup plan for that.
Just to add to this also applies to secrets, because service principals have passwords and IDs and all of that. And again, we're at the stage where each stamp is really separated, so they have even their own key vaults, and we have customers asking about this as well. Should we share key vault? Should we not? We say don't share your key vaults, just have a key vault per stamp and put all secrets for that stamp into that key vault. For things which are global, such as Cosmos, if you're not using private endpoints and managed identities, if you're using keys, you can just double the key and put it into one key vault and to the other as well, so that that stamp has its own secrets, own identities, everything own encapsulated.
Great. I think I have another couple of questions in the stream. So somebody said Terraform works great until your environment goes out of sync with the state files. I think the recommendation is never touch the system except with Terraform itself, so it shouldn't run out of state.
That's right? Exactly the point. So yes, we run into that too, but yeah, usually only when someone. And yeah, so the ideal state is that no one has access to a production environment. That's a different thing. Like no physical user should ever have like write access. Read access, okay, but no write access to production environments. And that usually alleviates that problem, because it can't happen that someone like touches your stuff and suddenly it's different than what Terraform is doing.
And the other thing is we have a delete lock on the storage account, which has the state file in it, and we consider it really sensitive.
Yeah.
Right. Identity access management, just lock it from everyone. Okay, I just want to mention something else. You always said, in case a region goes down. That is usually not happening, right?
So, that's a very good point. Yeah, so when we talk about regional outages, we usually don't mean the entire region goes up in flames. Hasn't happened yet, usually.
Ever.
Yeah, but we also mean like because what the more like likely scenario is that the critical service goes down in one region. Like let's say AKS in West Europe goes down or something. We would still consider that a regional outage. Yes, you could say now, okay, or like, I don't know, like if storage goes down in West Europe, you could say, okay, like I'm targeting the storage cross region and stuff, but usually becomes a lot more tricky than if you say, okay, we consider the region unhealthy and shift traffic over as a whole.
And also that is not happening frequently. Okay, we have another question in the chat. Are managed identities not global like front door?
No.
They are. No,
they're not. Managed identities are per region. So funny enough, like under the hood, it's still service principal, but no, they are, consider them a regional resource, yes.
How can you hide your backend services using AFD? Putting them in a network?
Yes, using private link.
Private link.
Yes.
Okay, I have a question as well, and we continue the Q&A after your second question. But my question would be, imagine you have a German, whatever, next fashion store company, which is only acting in Germany and has German customers, and you're talking about regions, at least 2, but recommended 3. What kind of region should we then use in Germany? Because latency-based routing, that might be a problem. We won't host it in Sydney, right?
So you want to stay in Germany?
No, yeah, right. My customers are only in Germany.
Yeah, so then you can deploy 2 stamps in Germany. So they will be still like 2 stamps, but in the same region. But since everything is zonal, there is redundancy, at least within that region.
But not on a regional level.
Yeah, but still the question, I would say, like, if it's a German company, a fashion company, they're probably okay to host in the EU as well. So actually, if you're hosting Amsterdam, West Europe, for some customers, West Europe will be closer than Frankfurt. Same you could like host in Zurich, like in Switzerland. So unless you have like a regulatory requirement that prohibits you from going outside of Germany, I would say still consider the regions around as well.
North Europe, West Europe, and 1 in Germany.
From the latency perspective, most workloads honestly won't like really feel like if it's 3 seconds longer to Amsterdam than to Frankfurt or so.
Okay.
Doesn't really matter, yeah.
Thank you. With that, I think that was the first session, and then we want to see you in action in the second session. We will start sharp at 6 in around 5 minutes.
Okay, thank you.
Thank you.
Okay, it's time to continue, and we will hear something more hands-on about the Azure Mission-Critical framework. We still have Martin and Sebastian here. And yeah, grab something to drink and then choose a seat, take your seat there. Yeah, please continue. Great session, great stuff. Thank you.
Thank you.
Welcome back after the short break. While people in the room still getting their food and drinks, that's fine. We'll start to continue, and I guess you can still hear us anyway. And for all the people on the stream, welcome back, or glad that you're still here. Yeah, next topic we want to dive a bit into is observability and health modeling, and why we choose the words health modeling we come to as well. Yeah, so the important thing is when something bad is about to happen, you need to know right away, right? That's the goal. Like when a mission critical application, that's obvious, but also like, I guess for any kind of application, more or less mission critical, that still applies. You want to know if something happens, something bad happens, and you want to know as soon as possible.
Typically before the customer calls.
And before someone tweets about it, hey, Xbox Live is down,
yeah,
ideally you want to know beforehand. Like,
hey, we talked about logs and how we structure logging and how we recommend to structure it, so I will not dwell for long on this. This is just to set context. So this is where we are in that colorful icon full picture. So now we're talking about these things. Let's get into it.
Yeah, so as we promised, like we want to do demoing here. So the next one is this one. Yeah. Yeah, so what we're looking at now, and some might be familiar with this, if you've ever seen, or if you ever used Azure Application Insights, that's what's called the application map. It's a super helpful tool, especially in distributed workloads. We have like a lot of things working together, right? So you have like in our case, we have what we call a catalog service. We have even the UI, which is basically here. There's no one browsing it right now. So the front end. But the catalog service is our API layer, basically. Then we mentioned we have event hubs in there for decoupling. We have our database back here, front door, so we have direct calls to the database, but we also have some asynchronous processing through the event hub queue to a background processor, and that one then writes to the database and does storage requests and all that things working together, right? So as soon as you have that, like it's super important to have like a possibility to see what's being, or to do what's being called distributed tracing, and then to be able to investigate where are things going wrong. And so first of all, here as a dashboard, you can quite easily see, okay, where are things like being stuck, for example, like we can see how long things are being stuck in the queue, like 92 milliseconds. That's pretty good for us, but
it's not stuck.
It's not, so it's sitting in the queue for 92 milliseconds, which I would say is pretty fast, but maybe for your application, that's not fast, right? Maybe for your application, like 30 milliseconds is totally out of line already. Totally bends up to your needs. We can see here that's very, very dark red there, but actually only 0.1% of requests that have somehow failed. And then from there, you can directly dive into. You can see, okay, what are the top failing status codes, and you can investigate failures from here. Yeah, you can see, okay, how often did that happen? So overall, it really, again, like maybe you're interested in 0.1% mistakes. Maybe you say, okay, we just accept that. So I'm not diving into this error right now. But another thing that's super important, and when it comes to distributed tracing, like usually, and probably you've all seen this when you're browsing some websites and something going wrong, like you get some long ID, like please give this correlation ID to support request. And you always wonder, okay, how do they actually use that? Well, one example, if you're using application insights, could be like this. I picked the arbitrary transaction ID, or it's actually called operations ID. Not that one. Where's my copy pasting? If I paste this here in what's called the operations search, we can actually get all the logs and metrics that are correlated using this operations ID that are somehow in the context of that thing.
Sorry, just for the context, let's say I, as a user, clicked on the website, suddenly error page shows up. They show me only this number. I call Sebastian or send in an email. Hey, the app failed. Can you investigate? I give him this ID. He goes here and sees what happened.
Yeah. Yeah, the first thing I see is like, well, there's a lot of stuff here to see, a lot of entries, but I can also actually just click onto one. And what I can see now is what's very helpful, the end-to-end transaction view, as it's called. So we can see all the different, like basically similar what we saw on the application map, but a specific for one call or one call sequence and all the systems that were involved then. So the first thing is actually that's the catalog service here. So that got a get item request. Apparently, like Martin was browsing something. I can also see what URL he was browsing here.
Oh no.
And then I can see down here, okay, he posted a new item comment. Maybe actually we should.
It wasn't a nice comment, sorry.
It wasn't a nice comment. Okay, maybe I don't want to know what he actually posted. But yeah, so here we can drill into, we can see, okay, I went from the cluster, that's the front-end service, I went to the event hub, and if I can drill even more, I can say, okay, I spent like 43 milliseconds in queue. Then the background processor picked it up and put it in the database. So in this case, I tell Martin, well, everything went well. I don't see an error here. Must be user error. No, just kidding. Like if there would be an error, like it would show up here like in red, like I could see, okay, where did it fail? I can also see more telemetry, like here's also logs. So the previous view is what's called dependencies and requests. In here, I even like see individual log entries. Or like here I can see, okay, to the database, his call cost us like 3.1 RUs against Cosmos. Things like this are all visible through this one operation ID because we did correlated or distributed tracing here.
But the very important, and I want to just reiterate that the magical thing that's happening here, we are basically connecting two disconnected parts of the system. We have an API, and then we have the processor, and the API is not calling the processor. It's sending a message to a messaging bus, and the processor is picking that message up and continuing the processing, and it still has the full context. It still knows that it came all the way from the browser. That's what distributed tracing is doing, and it's super important to set it up properly.
Yeah, and again, like one of the reasons why you should use official SDKs, be it .NET or be it Java or Python, whatever you're using, because all of them are instrumented under the hood. They realize, like if you're using, for example, the SDK to send a message to Event Hub, and they see, okay, the incoming request was an HTTP request, which had a correlation ID already, it will automatically add that as a metadata to the Event Hub message and send it over the wire. And likewise on the backend, then where we, again, using the SDK to process messages, that SDK sees that extra property automatically and thereby continues the transactions there. So all the logs and metrics the backend processor is producing are already automatically correlated using that transaction ID. And again, we don't have to do anything there. Of course, you can enrich the logs, you can add additional metrics, what we've just seen there, add more logs, but the out-of-the-box experience is already there by just by using the SDKs. And of course, by connecting all of the applications to application insights. But if that's the case, then you don't have to manually add like metadata to messages or so. It's all there for you. All right, and with that, let's actually switch back to the slides for a moment.
The other part of observability, health modeling. I was looking for a definition of health modeling. Most of the sites I found were related to actual physical human health. So that doesn't help very much when I'm talking about cloud systems. So I just came up with my own. Actually, I stole it from one of our materials. My own is on the next slide. But health modeling is the process of quantifying application health in the context of business requirements and drive some kind of automated action. For simpler-minded people like myself, health modeling can be just using traffic light colors, green, yellow, and red, to show if your app is healthy or not. And you decide what healthy means, and you decide what kind of numbers do you assign to these states so that they are compliant with your business requirements. And I mentioned business, so it kind of suggests that this is not purely a technical exercise. Health modeling typically starts on paper or in PowerPoint or Visio, whatever you prefer. I like to draw these things down by hand because it really helps you to understand what your system is actually doing, what your application is and what it consists of. So you just sit down and you do this kind of top-down design where you see, okay, I have a website, and it has, let's say, in this case, two main user flows. And this is just a logical concept. There's no technology involved yet. I allow my users to list catalog items and add comments to them. And then what kind of system components support these user flows? I have some kind of web frontend. I have API. I have the background processor. These, again, we are not at Azure Services, Azure Resources yet. These are system components. And those system components are finally powered by specific Azure services, in this case, Cosmos, Azure Functions, or AKS, and Event Hub. And this gives me this nice hierarchy of dependencies where even on the paper, I can see that if, in this case, Key Vault goes down, it will bring together catalog API, background processor, which will then make list catalog items non-functional, add comment and non-functional, and in turn the website. Now, what does it mean that Key Vault is down? That's where we continue with this design exercise, still on paper, even though this is better done in Excel, for instance. But still, this is more like a thinking exercise, moving from experience and just assigning numbers to these individual states. So what does it mean that Key Vault is unhealthy? And what does it mean that it's degraded? Degraded means that customers don't know about it yet, but they might find out very soon, and I need to do something about it. So it might mean that the web app is not responding within 200 milliseconds. It takes 2 seconds to respond. I still get the response, but I'm not happy about it. So this is the second part of it. We have the health model design, we have the thresholds and the specific numbers.
Yeah, sorry, just to add one thing. So what you said is kind of implicit, like per service and per application part, you need to define which metrics are important for you. Like some might be fairly universal, like everyone's probably interested in like response time for the users, right? Application or like web application response time on the website. But maybe we saw earlier like Event Hub time spent in queue. Maybe that's super important for my app. And again, I'm assigning 30 milliseconds. I'm saying, okay, above 20 milliseconds is degraded, and above 30 milliseconds is unhealthy for me. Whereas like he says for his app, like, well, I want to know if Event Hub is there or not, but if it takes 2 seconds, I don't really care. Right? That's the context that you as the application team need to know and that you bring it in there. And that's a living thing. It's very important. That thing is not a one-time exercise before your app is running, but this is a living thing. You add more metrics, you add more queries to it, you adjust the numbers that you see there over time.
And finally, you visualize it. So this is basically taking the first and the second slide and moving them together into something which can be put on a dashboard. Because everyone's doing dashboards. They have all these charts and all these numbers, and it's colorful sometimes, but it still doesn't convey the right message. If I come to it and see that this number is 500, is it good? Is it bad? I don't know. The person who's operating it for 2 years, they know that, oh, this is bad. It should be 10. I don't know that. But if I see a yellow or red color or a point or a circle, I immediately know something's wrong and I can drill down. This is just an example. Sebastian will now show you something like that in motion.
Yes, and not just that I know, maybe actually to quickly go back for a second, not just do I know where, well, like what's wrong, I know where to start looking, like, right? Like if someone, like for example, if someone tells me, hey, I couldn't add a comment or something, if you stay on the right-hand side, I couldn't add a comment to my product or so, and you can see, okay, the background processor has a problem, but the underlying stuff seems to be okay, then I know where to focus. And vice versa, like if I see, okay, the cluster has a problem on the left-hand side, I immediately know, okay, if I don't fix that problem quickly, I know like both of those two user flows, like add comment and list catalog items, they are impacted. Whereas like show static content, that's still fine, but I know bottom up what will be the like the impact basically. Yes, and with this, let's actually go to a live one. So what you see now is still the same thing. Actually, the screenshots that they just saw earlier were not made up in Excel or something. They are like real things. I can move them around here. Right now, it's all looking great and healthy. That's good. So this is our application from before, deployed to Australia and to the UK. And we see both of the health models here.
Yeah, and internally, if we go to edit and see what's behind this, this is all powered by custom queries and custom functions in Local Analytics Workspace. So behind all of this is that unified sync for all the telemetry we collect within this stamp. So that's the monitoring resources, and we have queries over those. And they evaluate health score per resource, per service, whatever it is, and aggregate them so that it shows up here quite nicely. And in the end, it is still a dashboard. So even though I see that now it's green, I can scroll down a little and see, it wasn't always green. Like something happened over here and something even worse happened here. And I can go into individual metrics and drill down and really start investigating even from here, understanding that something's not right, what exactly is the indication, and then what very specific things and specific metrics went wrong.
Yeah, and of course you could still, on the same queries, you would still probably do like alerting, like if something goes unhealthy or even or degraded, you could still use the same queries to be alerted then. But the logic is the same. Like the important part is to have those thresholds defined and have the context defined for your application. Like you could say, like, okay, please notify me if the if catalog service goes down, and that could either be because of some query specifically there, like behind this might be like a .NET service, so you have like metrics on this one. So either this one goes down, or because the underlying cluster there, like you've like defined, CPU utilization on the AKS cluster. If that's spiking above 90%, that will have correlated impact to the top as well, and that will also trigger your alarm on catalog service, for instance.
And this logo is Grafana for those who wonder.
Yeah, so this is a custom dashboard in Grafana, or like a custom plugin it's called, which, by the way, all of this we mentioned is open source, so please check it out. You can build the same thing in Grafana if you want to as well. We often get the question, why didn't we build this in Azure dashboards? First reason, like it's not as flexible in building custom visuals like this one here, for example. And the refresh rate here is much higher. Yeah. All right. Next topic. Actually, we don't need to go into presentation mode. We won't stay here long.
We already mentioned we don't want people to touch our stuff. So when the application is running, especially in production, no human should be required or even allowed to change anything in there. We don't want configuration drift. We don't want someone to accidentally break things by changing settings. And we also don't want adversaries, bad people, to target our application and make it not work. So how do we interact and how do we make changes with the environment? The answer is obvious, through automation and through DevOps tools. In our case, it's Azure DevOps, together with Terraform, and others. Let's get into it.
Yeah, a couple of things we want to touch on, and the next is all demos and showing things in for real. The first thing we mentioned is IAC for everything, right? So every infrastructure as code, like the entire thing we've just seen, and we can actually look at the resources. It's all defined in Terraform. We have pipelines for build and deployment. Again, all build as YAML pipelines for Azure DevOps pipelines. The next part is very interesting and very beneficial. We see dev environments on demand. We can demo that too. Then zero downtime deployments. It's kind of like imperative. Like if I want our application to never be down, then it also means ideally we don't want maintenance windows. We don't want to tell people, sorry, 3 hours downtime because we just need to deploy like a minor version update for AKS. And that comes with the last point: no updates, replace hold stamp. We can actually see this.
This can be sometimes shocking to people. Like, how do you not do updates?
Yeah, exactly. Yeah, we don't do updates. That's a good point. Yeah. So this is our DevOps environment in Azure Pipelines. We have like currently 3 types of environment, and it's important to say types. We have like prod, of course. We have int, that's the integration environment we just looked at, and we have n number of end-to-end environments, as we call them, or also called dev environments. And n number means at any given point in time there might be 0. Like over the weekend, usually there's 0, or during the week there might be more than 1, depending on how many people will need them, and we'll see that. But let's actually start in prod. That's fairly simple. So prod is basically manually being deployed. Whenever we think we have enough stuff ready that we want to ship, then we say, okay, we run this pipeline. But it's not running very often right now, so I'm not going there. Instead, I'll rather show you integration, because that's running all the time. And we actually had some issues here, which is a good thing. In this case, to show. Can I make this smaller, the sidebar? Oh, thank you. Yeah, so actually, let me start here. So what are we doing here? So integration is our environment that we're running nightly. I mentioned this earlier. So every night we're deploying changes, and if you look closely, you can see there were no changes. Right? There's still the same commit ID on main, so we're deploying from main nightly, even though nothing changed. So now you might wonder, okay, why did stuff start to break? Well, okay, that was a different commit, but here it started work again. And that's one of the first benefits we realized why we do this. Like in a distributed system like the cloud, there's a lot of moving parts under the hood. Right? It's not like the big old server hardware that no one touched over the year, but like we as a cloud vendor, we do stuff like Kubernetes pushes a new update, Terraform pushes a new update, a new provider version, and whatnot happens. All kinds of things tend to change all the time, even though you didn't touch your code. And we've had a lot of those instances where sometimes, like, we wake up in the morning and we see our nightly pipeline didn't run for some reason. But then again, it's only integration, so it's not as bad there. And that's exactly the purpose. So by the time we need to deploy to prod again, usually you have enough time to figure out, okay, what went wrong. For example, there was a Terraform update that broke something. Or good other example is like we deprecate AKS releases every half a year or something. I'm not sure what the policy is, but like it's being announced way in advance that, hey, end of October, you can't deploy 1.24 anymore. I don't know, whatever. But maybe you just missed that update. Maybe you missed to update your application. And like if you're still running in prod, well, we can keep running, but A, you're usually out of support, and B, you can't deploy new clusters anymore. You might not realize that until you really try to deploy to prod next time, and that's a problem. We will realize that as soon as tomorrow morning we couldn't deploy 124 anymore, our pipeline will break. And that's the whole purpose of doing that all over and over again. And if we actually look into one of the ones that worked, you want to walk through it? Or?
Yeah, so once do we want to start with the code or later?
Yeah, good point, yeah. The other window.
Find it.
Sorry, yeah. Like different identities here, so different, sorry.
So one of the things we learned when we were developing this is how to code templates in Azure DevOps. We are using YAML-style pipelines, so the newer ones, and we basically reuse most, I don't want to say the percentage, but most of the code across all these pipeline types. So end-to-end integration and production, they're basically the same code, just different parameters, and there are a lot of ifs in them. But in general, everything, and you can see yourself, this is open source, everything is split into those templates, which one could be interesting. Let's go full release.
It's the biggest one.
There's usually a set of parameters at the beginning, and then a set of steps, which are filtered or not filtered based on those parameters, based on the type and all of that. But in general, there's a lot of YAML code.
Yeah, so why is the templating important? Because you just said it, we're going to reuse the same pipeline code across different environments.
So in just a quick example, we have normalized, standardized set of steps for load testing. So we just reference it here as a template, and then just provide parameters like where to look. And that way we can be sure that we are deploying pretty much very similar things every time.
Yeah, so by the time we deploy to production, the code that we're using to deploy to production is the same code that we used to deploy dev environments and that we've used to deploy integration environments, right? It's not a completely set of different pipeline code, as different parameters, but it's like the same set of code that we've also tested. If the first time you run your code is when you deploy production, well, that's a problem because things might go wrong there and things will go wrong.
Where's ADO?
ADO is just...
I'm lost in your windows.
Oh, Windows 2.
Oh, this one, yeah. So what it does, I will not go through all of this in detail. Like, there's no point, I think. But every time we deploy global infrastructure, so that's the top box. And then we deploy individual, we call it release unit, but these are basically the stamps. So it goes through the regions and deploys regional resources. In parallel, it builds the application because it doesn't depend on the regions, the build of the code. Then it deploys configuration of the AKS clusters and everything else. Deploys the application itself. So whatever was in the repo at that time of the run, in main branch in this case, it will get built and deployed. We have some import jobs, and then we run kind of extensive testing, and well, not too much, but a very important set of tests. Especially smoke tests turned very important and valuable for us, because immediately here we are testing the individual stamps and we're validating that that first deployment, that it even worked, like even this, like is the app running right now on the stamps themselves? If not, it doesn't make sense to continue. And we are using smoke tests for this. We're just probing if the application is working. If it is, we start the traffic shift. So directing different percentages of traffic, this is int, yeah, different percentages of traffic to the backends until we are at 100% and we are sure that everything still works. In production, there are actually manual gates for this. So someone has to approve, and it can be tomorrow, it can be after a week. It's up to the process, but someone has to go in and manually approve that it can move forward. On int, we are not doing that. We're just letting it run through, but we are gradually shifting traffic. On the inside, actually, what's not seen here, what's kind of hidden to the pipeline, but in the code it's clear, we are doing blue-green deployments. So at the point of this, actually at this stage, there is already 2 versions of the app running on the, I don't want to say on the cluster, it's in the region. So we have the old version as one stamp, and we have the new version as another stamp in the same region.
And old version basically means the one from last or from previous night, right? Because
from yesterday, yeah.
we deployed every night, so we have the version from yesterday, which might be the same code version as today if there were no commits, but there might be differences.
True. So these directions is between those 2 versions, old and new. And once there's 100% on new, we test the global endpoint. So that's coming through front door. So that's how end users will actually come into our app. And if that works, we also have like the screenshots, right? The UI tests as well. So we even click through the user interface artificially and test if that works. And only if that works, we destroy the old infra, the previous version from yesterday. And we apply this to our daily deployments, but we also apply it to updates. So when there's a new version of code being deployed, we actually run through a very similar process. And only when we really knew that the new version works, we destroy the old one. So then we can be sure that if something goes wrong with the new version, the old one is still around, and we can turn back at any time very quickly, because it's just a front door configuration change.
Yeah, we can basically see this if we take a look at the prod pipeline. And again, it wasn't executed in a while, but it still looks the same. Let's take this one. So this is a prod deployment, right? And we can see the exact same steps that we just saw for int. And we can actually see like one check passed here, like, and there's more checks passed. Those are manual approval gates, actually. So here, we also start with like less traffic. On prod, we are very conservative. We start with 10% traffic and then 50. But again, it's exactly the same pipeline, right? That's what we showed earlier. It's the same pipeline that we've tested for days or weeks already before that on int. And we know the pipeline works. So we're running the same pipeline here with different steps on, with different traffic steps, basically, and different approvals here. So that's what Martin mentioned in prod. Before the approval step, before the destroy step, there's another approval. So maybe, like, even though all the traffic is now on the new release, on the new release stamps, we still let the old environment sit there for like a day or like a week or whatever you want, just to be sure if anything goes wrong, we can just quickly go back directly to the old stamps. And the same is, of course, true. Like, well, like if we like realize after like 50% of the traffic something's going wrong, still the old stamps are still there. We can directly move all the traffic back And the way we do this is just by reconfiguring front door. You've seen the weights before, where the weights were 50-50. While we're doing this, like basically we need to look at like 3 a.m. in the morning, you could see our int pipeline running, and for then a while you would see the traffic shift between the new and the old versions there.
What about Kubernetes rolling updates? Are you doing that? No, we just don't. We just scrape the whole cluster and create a new one with the new version of that.
Other way around, but yeah, we create a new one first.
Yeah. The same goes to Kubernetes updates, or basically any upgrades to the infrastructure. Just the old one goes away, and the new one rises and shines from that. So someone called it, I think, Phoenix update process. It just burns, and there's a new one following that.
Yeah. And yeah, so the important thing, we use the same update or the same deployment process, not update, but deployment process for both infrastructure, pipeline, and code update, so application updates, right? So it doesn't matter if we want to update the UI or if we want to change the Kubernetes version, we have one process that we follow here.
Just reiterating on that, because we can see it here. These steps happen every time. Deploy infrastructure, build code, deploy. It happens every time. So if at any point someone, myself, during the night don't have anything better to do, I just go to the infra, I change settings here and there. The next morning, it will be reverted because it will be basically redeployed. So there's zero configuration drift. Whatever is in source code is deployed. Well, not zero, it's like 24 hours maybe, potentially, but the point is that we revert any manual changes as soon as possible.
Yeah, and then the next thing we want to show is the dev environments. That's another very interesting thing. Yeah, so the last type of environment that we have, I mentioned, it's called end-to-end. And the way we use those, again, we could have called them dev as well, but we call them end-to-end for some reason. That let's quickly look into this one here. Yeah, so this one's actually our what we call component update branch. So we're using GitHub's Dependabot, so it notifies us about any like NuGet and NPM packages and new Terraform versions and whatnot. And we actually just bring them to a separate branch. This is called, well, I think it's called the component update branch. Yeah, and we want to test if all the updates are working before we merge to main. And that's what we have this pipeline for. And you can see again, it's exactly the same steps once again, right? All the same steps. There's a little difference here. We don't doing the 50% traffic shift. We're going directly to 100%. Why? Because what we're doing here is we're bringing up a completely fresh, independent environment. So that's what we call our end-to-end environments. This one will stand up all the resources, again, in a smaller configuration, of course, maybe like an AKS cluster with one node only in one region. We're not doing 5 regions here. Like a very small configuration of Cosmos DB, all that stuff, but it's exactly the same process. It's exactly the same code and exactly the same infrastructure, but it's fully independent. It gets a nice, what we call like a resource prefix, and we can test all the stuff there, and we can actually leave this running completely automated. So we just leave this running. We can see it takes like 55 minutes, including resource creation, so standing up a new AKS cluster, deploying the code, building the code, deploying, and so on, and destroying everything in the end. And this is fully automated, right? So by the time I'm looking at the pull request from Dependabot to see, okay, like, does this change anything or does it still work? It's already validated if it works or not. And the second way we can use this pipeline is actually if I go to here, to end-to-end pipelines, and I say run pipeline, I do this manually. And let's say I'm working on a branch. I'm working on, I don't know, feature API path right now. I can say, okay, I want to run this pipeline for myself, and I actually don't want to destroy it right now because I'm working on that stuff and I need to test some things. Maybe I want to play around with it. I want to actually go to the AKS cluster, log in, and try stuff. I can run this pipeline, basically, again, the same pipeline without the destroy step in the end. And what I'm getting then is my own set of environment. Oh, why is this so hard? Let's go here. So if we see this now, this is our subscription where we deploy all that stuff. We see a number of MC end-to-end environments. And again, we can see they have different prefixes. And that's exactly this right now. I think we have like 2 different dev environments running. And if I click into one of them, I can actually see a tag here, and I can see, okay, which branch was that from? I can also see who deployed that thing. Oh, it was me. Okay.
Blame.
I can see when it was last deployed. Like if I see an environment running there, or like sitting there for a week, and it was deployed by Martin, I might ask him, hey, are you sure you still need that thing? You could also automatically say Friday evening, we just destroy all of them. And if Martin needs it back on Monday, he can bring it back on Monday, right?
Thanks.
But yeah, otherwise it's super helpful and like really increases developer productivity because he doesn't need to ask me, hey, can I get our test environment? Like, can I get like 2 hours on there? Yeah, you can, but you have no idea what I've deployed earlier, right? Like what I played around with.
And we saw this with customers. Like they have like 3 or 4 developer environments which are shared, and they need to wait until tomorrow to test a new feature in integration or in the cloud in general. Or someone else changed some configuration for the tests, and now I inherit this environment, and I have no idea what's configured there. So this basically eliminates it.
Yeah, and of course, the obvious question you always get, hey, isn't that super expensive? Well, yes, it's more expensive than if you just have one shared environment. But well, we're running them in a very small configuration, right? Like might be like a minimum cluster for AKS because we're not really load testing them usually. But again, they are only like there as long as we need them. So we're not running our dev environment overnight, ideally, or over the weekend. But the other thing is, and that's often overlooked, like what you gain in productivity is really huge because like people can develop much faster, and B, you also gain a lot of confidence in what you're deploying and what you're merging into a main branch. By the time it gets to main, you know it works because you've already deployed and like tested on something that looks exactly like main. And we all know the later you find bugs and issues, the more expensive it gets. And doing that, like doing those full fidelity dev environments, like really like gets you there much earlier in the development cycle. And that's where you save a lot of money then in the end.
I think in the last 10 minutes,
we might
want to show the coolest thing.
We want to do some chaos.
We want to do some chaos.
Yes. Actually, we're going to quickly go back to the pipeline because we have that there. Yes, so quickly, if I just say here, I don't want to run it, but there's 2 checkboxes here when I run this end-to-end environment. One is run load testing, and actually if I say run chaos testing, the load testing is implicitly also executed. I'm not doing this now because we already did. But what happens if I run this pipeline, this configuration, we can basically see here. Again, it's the same pipeline that we've seen a few times now, but here at the end, like 2 more steps are being added.
And this goes back all the way to what I said at the beginning. We want this application to be always on, never down, whatever happens. And how do you know that your app is like this? You don't. And we actually figured so many things missing in the implementation, in the configuration, when we were doing these chaos tests on our own. Basically, we sat down, we opened the portal, and we started clicking wildly and deleting resources, killing pods, and then just observing how the app behaves. This here, chaos experiments and load tests, automate this so that you can do continuous validation. You can validate continuously every time you make a change, or when you're preparing for a release or a major change, that it still works, that even though pods start failing or infrastructure starts failing, your app will still recover. So there's a relatively new Azure service called Azure Chaos Studio, which allows you to inject chaos into your applications. And there's another new service which went GA recently, last week, which is called Azure Load Test, that complements it very nicely because inducing chaos into something nobody's using doesn't make much sense because you won't see the chaos. So that's why these 2 work together. And that's why we have them here in this pipeline. So we start a chaos experiment and we run load test. And I don't know your tabs, so you can probably show that.
Yeah. Yes, the important thing to remember is like what Martin said, like what we did earlier, like or to begin with, was more like manual experimentation where we really went ahead and just killed stuff and just observed what's happening. And it's super valuable. Please go do that. Not in production, but on in test systems, please go do that. It's super valuable. That wasn't that's not what we're planning on doing here. Here, it's really more to validate that the resiliency measures that we've taken in our architecture and our design to validate that they are working. As a concrete example, what we're testing here is like we've deployed 2 regions. So this is a bit of a scaled up end-to-end environment. It's not just 1 region, it's 2 regions. And we want to validate that really, okay, if one region fails, does front door work? Does our failover detection work? Failure detection front door works, the failover procedure, does that work? That's what we want to validate here. And you could validate all kinds of experiments there, but that's the one we went for here. And yeah, so we start load testing, we're adding some load to the system. In the beginning, both work nicely together, so there's no chaos yet. Then we're adding chaos, killing basically one region effectively, one of the two, and observing if the traffic is being handled nicely by front door and right redirecting. So how does that look in action? Yeah, unfortunately, that's where we run into an issue earlier. Otherwise, we would have done this as a live one here. So what you can see here is basically a load test. So that's Azure load test. Actually, yes, let me start from there. You can see it all the way. Torsten mentioned it earlier. So yeah, it went recently GA. So this is all fully automatically created by the pipeline. So again, no one went here. And most of the time, we never go there because the pipeline can also automatically validate if your test was successful or not. So in this case, we just left it here that we can actually see it. And I can see all my different test runs. I did a few more manual earlier, but basically the pipeline just does one, and if everything works, it will destroy it again. So we can see, okay, how much requests were added, what's the duration, but more importantly down here.
Maybe for those uninitiated, what Azure Load Test is doing, you provided a JMeter load test file, which is industry standard format. You can edit it in normal JMeter, which many people use. It's a JMX file. You upload it here. You configure how many virtual users you want to apply on the target endpoint, let's say, URL. And Azure internally spins up all the necessary infrastructure, all the containers, virtual machines, whatever it's running to accommodate this kind of load, and just hits the endpoint with whatever scenario you configured in the JMX file. In our case, it is list catalog items, get random catalog item, create a new comment for it, and
Post new comment, yeah.
That's it.
Post rating, post comment.
And post rating. So it's kind of simulating a real user, but in a super high and automated scale.
Yeah, so yeah, unfortunately, as I said, this is not the ideal case to show here. Usually what you would see there, again, this is only a few errors, looks like a lot, it's only a few. Usually the idea is, okay, we start small, we have a lot of traffic, which we did have here, 0 errors or close to 0 errors, and then suddenly chaos kicks in and you see 1,000 errors or so spiking, which is expected, right? Because we killing basically one region, and yes, we said we expect some degraded user performance for a short period of time. That's the important thing. Usually you can see after 2 minutes or so. Do we have a screenshot for that?
Yes.
Yeah. I think we did prepare a screenshot. Yeah, beautiful. Yeah, that's the one we wanted to show.
I will just unhide them.
Yeah, sorry for that. Usually we try to do live demos, but this one wasn't having us. Thank you. Yeah, so this is what it should have looked like. So yeah, at the bottom you can see the load being generated over a couple of minutes, and then that's where the chaos experiment kicks in. Where's my pen? Here's my pen, right? So this is where it kicks in. And yes, we see a very high error rate for a couple of minutes, or actually it's only 1.5 minutes about that, because that's how long it took front door to realize, okay, the region is down, and redirecting traffic away from that region. And that's here. The load test was still, the chaos testing was still running at this point, because the chaos testing was 5 or 10 minutes, and the errors were only observed for 2 minutes, basically.
And the chaos for us in this case was disabling pods.
Disabling all the pods, yeah.
Yeah, so rendering the cluster unusable, basically.
Yeah, and then we can see the load test was still running. Now you might ask, okay, why is the request rate higher while the errors were observed? Well, that's quite simple, because the errors come back faster, so they look to JMeter faster requests, but they were actually failing. But then here afterwards we can see actually the request rate is a bit lower than was before. Well, again, now we have only one cluster handling all the requests, but again the error rate is down. That's what we wanted to validate there.
We are very close to ending our session.
Yeah,
these are the 2 backends on front door. It's the same period of time. One backend is down, the other takes most of the traffic. This is another view of the same thing.
Yeah. So this is the health, the front door health, the health of the one origin going down, and the other one is still there. Again, here you can see nicely like front door almost doubling the traffic to the remaining one region. And then after the chaos ends, it brings it back to almost 50, or pretty much 50-50 there.
And to close out the session before they kick us out of the stage, we want to point you to the most important part of this
Go do
session. Go do. This is the call to action. Everything we showed you today is open source. There's much more. We develop it in open on GitHub. We accept issues and pull requests. We try to review them very quickly. So it's all here. Then the guidance itself is on Microsoft Learn. So there's a lot of text along with some images and tables.
And neat and nice videos.
And videos and all these demos. So you can read all of the guidance. Like I said, you can pick what's important for you. You can pick everything, of course, if you want. And finally, we also have like interactive materials on Microsoft Learn modules, where you can actually challenge yourself trying to design a mission-critical system, or we have specific courses on health modeling and continuous validation.
Yeah, the GitHub, if you go directly to the code, or if you end eventually have the code in GitHub, there's a getting started guide. So if you go through the getting started guide, all you need is an Azure subscription and like about an hour of time. And then you basically have the exact same pipelines and environments that you just saw on the screen. You can have deployed in your own environment and you can start playing around with them. So yes, go do.
And that's it. Thank you very much for being with us. We didn't lose that many people. So
yeah,
good.
Thanks so much.
Yeah. Thanks, Martin. Thanks, Sebastian. Was nice. And actually, I thought you would forget to show the people where they can start actually with implementing stuff or playing around. Great session. I hope that you still have a couple of questions. Let's see also if we have something in the chat. I hope you are still there for a couple of minutes.
No, we're running away immediately.
Does anyone have a question? Let's wait. Let's just wait. Okay, everyone.
Too intense.
It was intense, but I think we all learned a lot. There is a question. Yeah, let's see. Yeah, you need it.
It's for the people on video.
We have people watching us.
I'm wondering, like the question with the increased cost of such a kind of deployment.
Yeah.
Yeah, you already mentioned that it's more costly, but on the long run, it might be even, efficient to do it like this way. If I want to go back to the short run, like if I compare to other safe kinds of deployments, how much more cost can I expect with these? Like rule of thumb, I don't need a number like doubled 3 times.
You mean for the dev environments or for the like blue-green deployments for the dev environments? Yeah. It's super hard. Well, first of all, it depends like how many test environments are your company running today, right? Like some have like, as Martin said, like 5 development environments or test environments that people share, and like it's sometimes like no one uses them. They're still sitting there. Other times people waiting, hey, can I get my hands on one of them? So that's usually the biggest factor. Like how many are you running today? How big are they? And how many, well, of course, how many people do you have, right? Like if you have like 3 developers, like at most, usually we have like, I guess like 2 environments at the same time. It's rare that like all of us need an environment at the same time. Usually no one should get more than 1 at the same time, unless you have a reason for that. And again, you can automate a lot of things. You could really have policies to say like every evening I'm just killing them, right? Because it takes about half an hour to bring one up. So by the time you get your coffee in the morning, maybe you just make it a habit, you bring up your environment again. By the way, also a good way to test that all your stuff is in code, because if it's not, then it won't look like it, but if all is codified, then you can just destroy it and bring it back.
Basically, we're trying to avoid this kind of question in general, but the reason is that it's super hard because of the variety of solutions. Like everybody's running something different. So we don't know what the original development environment looked like, so we can't really apply it to AKS with 2 or 3 nodes. So it's really difficult to answer, really.
And in terms of the production environment, because you have the traffic split across regions, is there really an additional cost? Or is it measurable? Is it high? I mean, for example, you're choosing AKS. 3 AKS control planes, doesn't cost you anything. And then you have like the traffic split, like 1/3, 1/3, 1/3. It shouldn't, in theory at least, it sounds like it's not.
Well, it's not that significant, but during the blue-green, like we said, you have 2 environments of the same running at one point. So there is definitely increase, but yeah, it depends how long the whole deployment takes. So if it's in minutes, then it's minutes times the cost.
Yeah, but the number of regions, that's a good point. So there shouldn't be a huge overhead. Like if you do like 4 smaller regions or like 2 bigger, like they should ideally like not. There will be small overhead because like of course you have like some costs that you're always adding. But in the end, like what you're gaining is you don't need to over provision them that much for like failout scenarios or like or you don't need to scale them out that much. So yeah, like distribute as to more regions as you can. And again, if all is automated, really for us, it's just one configuration parameter where we say, hey, tomorrow we also want to deploy to West Europe. And then the next deployment will just add another region, configure it in the front door and all that stuff.
Great. Any more questions in the room? No, okay. One last question from my side. So are you allowed to talk about customer stories? Are there any famous customers that are using the mission-critical framework already?
Yes, we have a couple of public references. I think the most famous one is the NHS, the National Health Service in England, that actually both of us worked with at the beginning of COVID. So yeah, that is a public reference story, quite interesting case where we applied a lot of those mission-critical principles there.
Cool. Thanks, Martin. Thanks, Sebastian. Again, make some noise for this nice introduction. We will do a slightly longer break right now. So we will be back in about 20 minutes with our Microsoft MVP, Janek Fellien. He will show us a little bit about his enterprise serverless solution on scale, CQRS 3.0. See you soon. Okay, let's continue with our last session today. So I'm really happy to have Janek Fellien on stage here talking about CQRS 3.0, the serverless solution, and I'm really excited to see what he will be talking about. So let's welcome Janek on stage and have fun with your session.
That's the applause already. That's great. So hopefully it works here. Yeah, that's me. And I will start this session here with F5. F5, really. It is honestly, no, it's too cold here. Yes. Oh, no preview on my screen, unfortunately. So, welcome. It's my first time that I'm here on this stage longer than 10 minutes. Yes, I'm so happy. Yeah.
Do we want to extend?
It's not really necessary.
It's not there.
Yeah, I can talk about CQRS without any change of the slides. Yeah. First of all, this is a slide deck I have prepared for the build last year. We were here in Berlin, and it's actually a talk for around about 30 minutes. And as I had the first time I talk about CQRS, it was around about 6 hours. So this talk is something between 30 minutes and 6 hours. Of course. Yeah. CQRS, the serverless solution. Actually, if you're familiar with this topic, CQRS, if not, I will explain a little bit more. But if you are, you don't know what I mean with the version 3.0, because it's the only version number I have invented. There is no version 1, 2, or 3. It's just the version 3 from my mind. It's the serverless solution, but I will talk about that. What is the difference between 1, 2, and 3? First of all, let's have a look into the agenda. It's not usually that I have an agenda, but someone asks me, hey, Janek, could you please enter an agenda in your talks so I will see what you will talk about? I don't know what I would talk about, so I don't have an agenda, but today I have. First, I would start with talking about a little bit OOP. The most of us are, I think so. We are software developers, and we know what is an object-oriented programming and what is the way from OOP to CQRS. And this is actually also the same thing to describe from my side what is CQRS. And after that, I will talk about the types of CQRS. First of all, OOP, object-oriented programming. When you take the classical books about object-oriented programming, you will find this kind of classes. It meant you have to program. If you write a program, you have models or you have classes or you have things, and all the things do something. And here you can see a classic car. It has a price, a name, a color, engine capacity and horsepower and so on, and some values of that. And this is what you can see in the books and what the book says. But actually it's totally wrong. If you write an object in the real object-oriented programming definition, you have to split up the objects here. The car has some properties here. It has an engine as a new object, and you have wheels as a new object as well. This is what the books meant, actually. Back to some of my objects I've developed in the past. Many of you probably know what I'm talking about when I say master data management class. It's a little bit kind of UML here. And this master data management class has two functions or methods. Functions in this case, we have return values. For example, this get products, we take this ID, put this in the method here, function, and we get back an product. It's fine. And we have a second function that says, save this product here, the new product, and we get back an ID. I wrote this kind of objects so many times, so many years, that it's quite, it's right, it feels right, but it's totally wrong. From the perspective of object-oriented programming, is this object a totally wrong object? Why? The definition of OOP says you have an object which has only one responsibility. It has only one reason of existing, and you shouldn't mix the responsibilities in this object. Okay, let's take a look back to this object here, that master data management. Probably we have some properties here. It is fine. It's the responsibility to manage the master data. Nope. These are the responsibilities of an object, of our objects. We have this read and write. And this class here is doing two things actually at the same time, which is totally wrong from the definition of OOP. Okay? Let's solve it. The first approach to solve this problem is go the way of CQRS, command query segregation, which is invented, I think it was around about in the year 2000, 2006-ish, something. And it meant split it up, this object, into, for example, master data reader and master data writer. Okay, we have two classes now, and we have the responsibilities here to read something and write something. Is it fine so far? If yes, the talk is done so far. But it isn't. Why? Because a lot of people, as they found out that the object-oriented definition of doing something, only one thing here is, and we create this object, and oh yes, we have a lot of more classes here now, but it's separated now. They didn't know that, talked about this ID thing here. If I have a save, a write method, and I get a value back from this method, I know there's a read in behind. Oh, it's in the stream here. It's not really good. So this is really a problem. After a while, the people find out, or developers, or whatever, they found out, oh, it's a cool idea to put this ID in the new product thing here. And then we don't have a return value here. It's fine-ish. Okay. But usually you will find this kind of classes here, which is more, it's better than the first type of class. You have only one master data management class and doing all the stuff here. Yeah. So it's way better here. You have this read and write. But actually, you can see the ID. It's a read in this method. This is where the CQRS is kicked in. Command and query responsibility segregation. I will explain it in a very, 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 very simple way. My first contact to CQRS was in the year 2010, actually. It was the year that I've heard this name the first time, but in 2008, I had a talk, an internal talk in the company I was working in, and I talked about a principle to change or write the software in a different way, but I didn't had a name for that. And I explained it in a very similar way, like this CQRS. And later on, someone told me, hey, it's called CQRS. And, oh, great, someone has a name for that. I like it very much. And Greg Young, the inventor of CQRS, he and a friend of the community, Adam Dimitruk, they was there, had a long session in a bar somewhere in Vancouver. And they was very drunken, they are both. And they had a piece of paper and made some notice there. And this is the first documentation about CQRS. And if you take a look on this kind of paper, first you will see, yes, they was drunken. And the second one is, what the hell is this great? This is the solution. This is my silver bullet. Still. But this picture will be way simpler than the drunken paper. Okay, we have an application. We start with the UI. And this UI have an intention. Some users on the UI will do something. No? Any application we write, actually any application we write has two parts, write and read. And in some statistics they found out that we have 20% on the write side and 80% on the read side. Cool. But these two numbers, maybe it's a little bit different or no, or what, but it has a huge impact to the architecture we are talking about. In the right side, we send a kind of command, a message, to a domain. This is what Greg Young said, call it domain. I will talk about later that thing. This domain changes something, for example, the status of the application, and sends this status changes as kind of event to an event store. In any case, when I talk about CQRS, I bring it together always with event sourcing. So for me, it's one thing. If you take a look in some books or so, you will find some solution in CQRS without event sourcing, but I love it very much to put it together. So I don't split it. For me, it's the same, or it's something. It is always together for me. So we have this event store. Send some changes to this event store. And the second step is take the same event and send it to an event handler. Okay. It's the documentation of Greg Young, yes? Then the event handler changed something in the read model. And always the UI can send some queries to a query handler and gets the results back, more or less. This is what the two guys in Vancouver wrote down on the piece of paper with a lot of more lines and a lot of more boxes and names, but the aggregate of that all is this picture here. And the most interesting part here is this bubble called domain, because the domain is the hook for the people who are trying to do all the stuff in domain-driven design, like me. And we looked at this bubble and, okay, Greg says this is the domain. And does he know what we are talking about when we talk about domains? And yes, he was aware of that. He was completely clear that this is the thing that we describe the complete application, we describe our business stuff in it, and all the other things around that, it's just infrastructure. Okay, fine. This is the domain thing, you know. Domain-driven design and CQRS. We have the domain, and in this domain we have a few contexts. Actually, I should add an S in the end of context. And in the context, we have a bunch of aggregate It's not only one, but this is only a picture for later on, for the CQRS 3.0 version. You should know this. You should keep it in your mind. The domain, the context means you have this whole application, and you have some context, for example, sales part, and I don't know, invoices, things, and I don't some context. So we have to modelize your applications. And in the aggregates, you have the God objects here. The interesting part is that I don't talk about aggregates anymore. So if someone here in the room and designs application in the DDD style, let's argue a little bit about aggregates. But it's okay. It's from my perspective, it's necessary to know for the next parts in the talk here. Keep it in mind. Let's talk about this variants of CQRS. The first one, and maybe I will talk about the most things about this one, because it was my starting point. In any case, in any CQRS application, you will have an UI. So I don't put this box here in this picture, because the UI is always the same thing here. We don't have to talk about that. This command handler is a specific thing on the boundary of this domain. Or better to say, take this picture. We have this arrow here. We have this command, and somewhere where the arrow is touching the domain, there is a box called command handler. Of course, someone has to receive the message, the command, and handle this message. It's the command handler. And inside of a typical CQRS version 1 implementation or solution is you have an aggregate. Yeah. And this command handler gets this command, opens it, and gets an aggregate ID. And this aggregate ID tells the command handler, read all the data from the event store to this ID. Okay, I read all the data from this event store. It's E1 till E8, called event 1 to 8. In any event, you will find the status changes, and you have a list of events, and in these events, the data. So the first is the command handler takes all the events selected by this aggregate ID and take any event into the aggregate. And in the aggregate itself, we have this apply method. You will find it in any CQRS solution, the apply method, or something, apply event or something. In any case, you have this apply. Why we have this apply here? Because the first solution from Greg Young was a apply method somewhere in the source code. And oh, good luck for me. He is a .NET developer. He wrote anything in C#, so I've read this, read this source code, and oh, that's cool. Yes, this will work. No? But you can see this Zahnräder here. I call it rampa. Yeah, it's a kind of steam machine here. any event. The aggregate root takes this event, take a look, it's type of this event, then we need this apply method and put it in there, in this method. And this apply method takes the data from the event. Oh, okay, I will have to set up now here this property and run this method. And oh, with this thing, I have to do this one and this one and this one. So you can imagine it will rampa, steam machine. It takes a while of time, so that in the end, the result of all these events is that we have an aggregate in the last state of knowledge, the last state of the object. So, for example, what is the last state of the object? I'm a person. better. From the German perspective, I should say my wife is a person, because the example is better for my wife. So she's a person. And as she was born, she had a different last name than now, obviously. And the status of the last name from my wife has been changed. But the first event was that she was born, and the last name is XYZ. Güldenpfennig. I love this name, Güldenpfennig. So, and after we married, the last name of my wife changed to Fellien, of course. And this is a status change in her life. So the first event, she was born, the last name after the first change is the last name of the aggregate for my wife is Güldenpfennig. The second event, or something later on the events, last name changed, or she married something, the last name changed now to Fellien. That's okay. But usually if you have a typical enterprise application, you read the data from the database. What is the last name of this people? The last name is Fellien now because someone changed the name in the database. It's this. So not in the event-sourced environment. In the event-sourced environment, you know the whole history and the changes, and you can move through the event stream. Let's call it a stream. You can go to any timestamp and say, oh, the status of this aggregate to this time is this. Fine. I don't want to talk about the advantages of that. It's just a thing, and I love it very much. Okay, this is the CQRS version 1. And I love it because I had a project in 2010 for a small company, but with a huge impact for Germany or for Bavarians. I supported a project there, and we tried to using or implement a CQRS version, a CQRS application. And after 1.5 years, we were done with this project, more or less, and without any struggling in the software development and changing anything was very great and simple, and everybody understands what has happened here in the domain and so on. The first version of the same solution was developed in the typical 3-layer database access rampa enterprise thing, yeah? And all the developers said, oh no, I don't touch this thing. It's more or less Italian style, the spaghetti thing. And no, we don't like it anymore. And as I said, after 1.5 year development, we were so happy that it works, and it's so fast. It's extremely fast. Now, for example, in the older version, database query, one day, the consultants started the application, and the starting time was around about 3 minutes that the application was ready to use, and one query took around about 30 minutes just to read some data from the database because of this many database tables. I'll call it join, yes, and or the relations things and so on. It took a very long time. Our solution takes around about 3 seconds, the same query. And they were, what has happened here in this environment? What have you developed here? No? Yeah, we changed it into a event-sourced environment. Oh, great. Yeah, this project is still alive since 2010 in the same architecture. I love it very much. Okay, CQRS 1. We call it the apply method. Oh, a sample. Oh, we can take a look deeper than in the things. It's the apply version. And the only reason for this apply is that Greg Young developed this or showed us this example. Here, take this apply. Later on, if you're interested, we can take a look into this apply method here. It's on GitHub, and it's interesting for reflection here and find the values there. And oh no, it's crazy. Okay, the second version of CQRS. A few years later, I was done with this version 1 project, and I started a new project, and I said, maybe we can change a little bit more, because this apply thing, I don't like it anymore. It feels not really cozy. I like a little bit more streamy stuff. Let's call it streamy stuff. Yes, I like it. Because in the .NET, I think it was in the .NET Framework 3.5 or so, roundabout, we started to get this system link namespace. And it was that huge thing that changed all the thinking about this CQRS things and eventing things and so on. And we took the same stream of the events here into the command handler, and we move all this, the whole stream into the aggregate. Okay, without any apply. Why? Yeah, because system link. When I want to look, or when I want to know some specific information about this entities or of the properties from this aggregate, I can take a search on the stream using link. I have the type of event. For example, married. Someone married. Okay, in this event should be the last name, the last version of the last name from this person. So let's system link. I take the stream dot of type married, and that's it. And then go to the last of that, for example, and you have the last name. Why should I use an apply method to find the data, open the event, take it, put it in, next event, oh, update this, oh, update it again, and so on? Why? I can take the values from the stream. And I have, this is actually the point that we are talking about domain-driven things in this part, because I need knowledge about why the status has been changed, because the last name has been changed if someone has married or they scheiden lassen. I don't know what it was in English. Divorce, okay, and so on. So you have some of the events there, and you need this domain knowledge here to find the right values. But it's cool because you talk with the domain experts. Oh, what is the reason? Why can something change here or whatever? Huh? And in the end, you have a few link statements to get the right values. Great. And you have logic there. For example, is it possible that someone can marry if the person already married? No. But you can take a look into the events. What is the last? It's not diverse, so it's still married. So you can't. You have business logic on the stream, which you hadn't before in the apply version. I love to work with this stream. I'm totally fine with this thing, and this is the moment that we in the community, in the DDD community and the event source community, started talking about projections. We can define some projections in kind of objects. Yeah? Take the stream, put the stream into these objects, and you get a result without any database. Everything works in the memory, and it is fast. That fast like light. It's the fastest database ever. You don't need the whole stream. Why? You need only the stream for this one aggregate. You have, for example, if you have roundabout, I have one example, 2 million events, and it's milliseconds in the requests. Milliseconds by millions of events, 2 million. Great. The fastest database ever. I love it very much. But we have the third version of CQRS. Why? It's so cool. Why do you invent a new version of that? Because it works very well, yeah, on the infrastructure-oriented systems. For example, in your own database or under your desk or in a virtual machine, something in the cloud or in the things here in the cloud. But in any case, it's a computer. It's only a computer or a few computers, and they do something here. In 2016, I had a first touch point to Azure Functions. And it was actually the same mind-blowing thing like in 2010 as someone told me, this is CQRS. And the first idea was, oh, I have to merge this. I have to marry this thing, the functions, the serverless things, and CQRS. I need a way for that. I didn't use this or created this in 2016. It took a bit time more, but first recap this again. So we have this UI here, we have the domain, we have the command here, we have the query again, we have the event in the event store there, and the event handler, read model is a database too, query, and for example, or just to tell, this read model can be a classic RDBMS, can be, but it's not necessary. The same is for event store. We can take a different solution here. Okay, just this picture to bring it back in your mind. And again, remember on this domain, we have domain, context, and aggregate in it. CQRS 3. We need a sound now, so it's an angel sound. What? We don't have. Okay. The command. The first thing is very different to the first version. That's why I've entered the UI here again. The first and the second version of CQRS didn't have a kind of messaging system. In the most cases, the kind of messaging system in the backend, they don't have. Don't ask me why. I never developed it in this way. Because I can, I don't know. But in the definition, as Greg Young said, the first touch point of CQRS is a command. It's a service bus thing. Send the command there into the service bus. The service bus sends, or we have a function which has a trigger listener on the service bus. And where is the domain? He started with context. Isn't it wrong? No, it isn't. In the talk before, you have seen that they had some resource groups. I take the resource group as domain. Why not? The domain is just a concept, the same as a context and aggregates. From this point on, I never talk about aggregates anymore because the aggregate is just a concept in the stream of events. I can take these events and aggregate this in any kind of information I need at any time. In the older version of CQRS 1 or 2, actually only in the 1, you don't have the chance to aggregate the stream in different meanings. You have only one result of after the applies happen, you have the last version of your aggregate, that's it. In the second version of CQRS, you have the stream and you can create some projections and you can create some or have some meanings. Okay, it's fine. But here in this case, I changed it a little bit for me, in my mind. I don't have any kind of aggregate anymore. In any case, I need some specific information. I create a change or update of this context function. deploy it, and I have a new information, and the whole system isn't touched. The rest of the system. Okay. I will talk about this custom binding a little bit later, because actually the magic is here. So I have this custom binding here. In this context, I do the changes we need. The domain expert says, yes, if someone has been married or something, the last name has to be changed. This is developed here in this specific function. This function has actually exactly the name of the context we found out with the domain experts. So when the function is done with the changes, it sends an event to the Cosmos DB. This is the event store. I take the Cosmos DB because of a very specific reason: performance, simplicity. Because the event it's a JSON object. I take it and put it in the database. That's it. No mapping. Great. And since this week or last week, we have a new GA on the Cosmos DB. I will try it out later on, because I have developed this here in the Cosmos DB manually. We have this hierarchical primary keys. Oh, I love it very much. Why? Oh, I will talk about it later about that. Okay, so first we store this event in the event store in the Cosmos DB, and the second thing is the custom binding takes this event, not a copy, it's actually the same event, and sends this to a next service bus. Okay, surprise, surprise. On this service bus, there is it's the next function called event handler. But this event handler is related to this context. So actually it should be the name contextual event handler or something like that, maybe. Yeah. And this event handler, surprise, surprise, the same thing as before. We take the data, put it in the Cosmos DB again, because we have changes and we put it here in this Cosmos. It can be a RDBMS too. And then we have the query handler, again as function, and take this query. And in any case, anything here is more or less a serverless thing. I'm software developer since around about 26 years. And I'm a little bit gray-haired now because of the infrastructure I've set up all the years before. And as I have seen the first time, or I had the first contact to the serverless resources from the cloud here, I was so happy. Oh, I don't have to deal anymore with infrastructure. Let's do it someone else. It's not my job anymore. I love it very much. Later on, I found out that I worked with serverless components from Azure since 2008, because the storage account is serverless by default, for example, and it's the first service, one of the first service from the cloud. Okay, this is my solution, and the most magic thing here is this custom binding. This is something you can have only in the Azure environment. Unfortunately, because AWS don't have this custom binding things. As far as I know, maybe they don't. They have it now, but as far as I know, this custom binding is a very small library, which is contacted as a binding on the function, and in this command there is an ID, the ID for the aggregate, yeah, and the first thing is the custom binding takes this command first, before the context or the function restarts, takes the data from the command, go to the database and prepare the data, the stream, the event stream in the database. It's just a prepare, not read. It is prepared. Then the custom binding tells tells the context, oh yes, now you can start to work here. But please inform me if you have some changes here. And then if the context has been changed, they take the event as object and says, hey, custom binding here. I have a new event for you. And this is the moment that the custom binding oh, I have this prepared stream here. Okay, it's fine. And this event, it's new one, it fits here in the stream. Yes, it's fine. Okay, you can do this. Or you can take a look in the context source code itself. You can take there and can take the custom binding there and ask, okay, binding, please tell me, did you have already this kind of event in your stream? The prepared stream, the custom binding takes a look. Oh yes, I have this already, and you can send the message back to the service bus, for example, and you have some listeners on the eye and so on. I've used here a signal R in there, and you can tell the user, oh, sorry, you can't store the data here because you have it already, or something like that. Yeah? Just to say. So, to say, the interesting part here is the magic in the custom binding, actually, because I can do this. It's a very, very small library, just to read some data from the database on an ID and prepare it as an event stream without reading, except you need some data from that. Then the readers happen, but in a very small thing, very, very small footprint. And you know, the most of you know that the Cosmos DB is a little bit expensive if you read a little bit too much. But with the new hierarchical ID, primary key, it will be solved, I think so. Okay, this is my solution at the moment. It's my silver bullet. It's one of the reasons that I'm in the company I'm working for, that they said to me, hey, yes, join us because you have this knowledge about the server thing and the event things, and we need it. And yeah, since a few, let's say years, I do only this way on development. Maybe I will change the context and the functions here more to the container apps. Maybe, maybe not. We will see. But this is my current state of the art CQRS 3.0. It's not necessary, maybe, but it's really, really cool. Thank you very much.
Great. Thank you, Janek.
Questions?
Yeah, questions. Does anyone have a question? Or do you want to ask a question? No.
I have asked a question. Questions?
Okay. Who wants to know something?
Okay, beat it.
Probably you answered all the questions already in your
Maybe.
Does everyone know what CQRS means? I think you haven't told us, right?
I have.
Yeah, sorry.
Yeah. Command query responsibility segregation.
Yeah, of course. Okay, then, thank you for being here today with us and also for being in the stream. Thanks, Janek, for that very interesting session. Now I know what that means, finally. And I'm not only meaning the abbreviation. With that, we will be here again in the next month, in March, and we will have a dedicated series about web development. Chris Heimann will also be here. And with that, I wish you a nice evening. Have fun, and we will see us next time. Thank you for being here. Bye-bye.
Ich bin schon auf. Bye.
you.